deliver his talk.
Welcome to Getting to Continuous Testing. This is a case study about some previous work that I had done at another client. I'm really excited to get to talk to you about this today. Actually, I'm excited, I get to be the first talk actually of Test Automation Summit 2020. Welcome. This is actually a recorded talk because it is actually 3 a.m. my time. I am, however, on the line, so if you have any questions, feel free to throw them in chat. I'll try and reply back. However, I'm not going to be able to answer live via this video, and I will be available for some panel discussions afterwards. So please ask away during and definitely afterwards. So my name is Max Saperstone. I'm the VP of Testing Solutions at TestPros. I've been working with TestPros for about 6 months or so, and previously I was with another company, which is actually where I performed this work. I've been a consultant for about 8 years or so, so what that means is I have seen the good, the bad, and the very, very ugly. And I really have seen a lot more bad and very, very ugly because the nature of consulting work typically is, well, people don't bring you in when everything is working properly. They bring you in when there's a problem. And so I've gotten a lot of experience of seeing what's gone wrong and good ways to course correct. Not all of my experiences have been a success, and so a lot of learning is understanding where we've gone wrong and fixing that. And so I can kind of talk a lot about that. This particular project actually started off really, really well, and as you'll hear, towards the end kind of deviated a little bit, and they took a lot of bad turns. And so there's a lot of lessons learned that you can take from that, and I'm going to talk about that a little bit as well. As I said, I work for a company called TestPros. We're an independent IT assessment and security services company, so we really focus on IV&V, on independent and embedded testing, and security within the overall testing and IT space. So before I dive into the case study, I want to spend just a few minutes talking about what continuous testing is, just so we're all on the same page. The idea is, you think about your typical testing cycle, and what you really want to be going for, what you're really looking for is to be constantly testing. It's that highlight of continuous testing. Typically, most of your testing takes place much further to the right. The developers do their work. They eventually, you do the requirements, you do the development work, and then eventually stuff's handed off to testers. And what you really want to do is you want to start testing a lot earlier on. That might mean that you're doing things like behavioral-driven development when you're talking about tests earlier. You might mean you're doing things like TDD, test-driven development, where you're actually writing tests against code early on. And, all these different activities are really just about how can we test the software as frequently as possible. Really, the whole idea is, we all really need to be responsible for quality, not just the testers. I cannot test quality into the software. All I can do is point out where there are potential flaws. And so if you're thinking about quality earlier, if you're testing earlier, you have this whole team mentality about quality, then you can be much more successful in having a high quality software that's actually doing what the end client wants. And that really is the whole idea about continuous testing. Starting thinking about testing and perform as many testings as you can when you initially talk about the release, and then testing all the way up until you're finally ready to deploy into production. And sometimes it even means testing in production. There's the big hot topic, DevSecOps, which is doing security within your DevOps, which is stupid because you should be doing security constantly. DevOps does actually include security, so think of this as your DevTestOps. Obviously you need to be testing to be doing DevOps, but if you want to be very explicit, that's exactly what it is. So with that, let's talk a little bit about the case study. Let's start off talking about a little bit of background on the client, just so we're kind of all on the same page. So this was a company who had a major contract with the NIH. For those of you who are not familiar, the NIH is the National Institute of Health over in the United States. And this was a contract that had spanned over multiple years, and basically they needed some test automation to be done. They recognized that they were having quality issues in production, and that their release cycles were incredibly long. They would take them 1, 2, sometimes even 3 months in order to fully test everything out. And even then, they were finding issues in production. And so what they really wanted was an automated framework that can test their entire system. So they brought us in and they said, all right, great, build out a proof of concept so we can do this. And I had a whole bunch of discussions initially saying, hey, this isn't a great idea. We need to kind of take a quick step back and understand your current system, understand who your testers are, understand what the developers are doing, etc., so we can build you the right system. And we actually initially got a lot of pushback on this, saying, nope, what we need is this, please build it out for us. And you'll notice that this is going to be a continual theme. So I had, longer discussions with management, etc., explained what some of the concerns were with doing things this way. And eventually, it came down to, look, this is what you need to build. And this is what we want. And so we decided, all right, great, we can do that for you. And so what we ended up doing was trying to build out really a minimal viable product, an MVP for them, with really as few features as possible, only getting exactly what they needed. We really wanted not to over-engineer anything, so that as we did discover more about their system, as we did understand more about their workflows, etc., we could go ahead and update things and it wouldn't be too difficult. Now, mind you, what I'm talking about is just doing some automated testing and building out a framework. By no means did we really think or even have any idea that we were going to be doing something in the realm of continuous testing. Quite honestly, when I started this project, continuous testing wasn't really a thing. It wasn't a buzzword out there. Of course, it's not a new concept. People have really been striving for continuous testing for a while because, of course, I want to test as frequently and as rapidly and as continuously as possible. But it wasn't really kind of this concept. But what ended up is, by going down this path and by following a lot of these steps, we were still able to accomplish something that really was continuous testing. So as I said, we were really just brought on in order to build out a framework. And we weren't, really asked to poke around and do some investigation, but as we were kind of building something out, that's kind of what happened. We found out some more information, and then we were able to tailor our framework and our system a little bit more towards what the end users would actually be wanting. So some of the things that we found was, well, there really was no automation. When I say no automation, I mean there really weren't even any unit tests. There were no functional tests. There were some integration tests. And when I talked to some of the developers about them, they said, oh, of course we have unit tests, but we don't really run those anymore. And when I asked why not, they go, they don't usually work. So, that's great. You can't really claim that you have unit tests when nothing happens. When I dug in even more, if a few people had some what they called unit tests residing on their system that they would run, and that's a start. And when I talked to the lead developer about this, he goes, yeah, and he showed me some of them. I said, well, these aren't unit tests. These are component tests. These are integration tests. These are much larger. And he goes, I know, but it's something, and we kind of want to be encouraging people to move in the right direction, which made a lot of sense. One of the other things that came up is I found out that we were actually the fourth company who was brought in order to work on this, which means 3 other organizations had come in and they had failed. For me, that was kind of troubling because I wanted to know why had that happened, because it kind of sounded like I was being set up for failure. And what I eventually found out was that because the QAs had little to no automation experience that were currently within the organization, and people had developed these massive frameworks and said, hey, here you go. Here's this framework. It's all built out in Ruby. Here are all the capabilities. Here's some documentation on how to use it. Go ahead, write more tests and use this continuously. It was not baked into any sort of pipeline. It was not something that you could just run in Jenkins or in any other automated build tool. It was extremely heavy, and it didn't necessarily follow their needs. When I dug in a little bit more, I found out they're not even a Ruby shop. For whatever reason, 3 different organizations, and I actually got to look at the code. All 3 of them had done stuff in Ruby, and no one in the org really knew Ruby. So one of the very first things we did, we said, well, clearly we want to make sure that we don't do those 2 things. We're not going to be writing stuff in a language that no one understands. And we want to make sure that we're building something that the QAs can actually use without too much difficulty. We found some other things, like they had no formalized test strategy, no real test plan, no real list of test cases, which again was a little bit disconcerting, but at the time was a little bit out of our realm of spheres of influence. And so we said, all right, we're going to keep this in mind because it's going to become a problem when it comes time to actually start writing automated tests. But for right now, we understand the system and we understand some base requirements of what it is that we're going to be trying to build. So what we ended up doing was building out a test automation framework using Cucumber JVM as the base for it. So for those of you not familiar, Cucumber JVM is a Java-based behavioral-driven development framework that allows you to write BDD, Gherkin-style given when then tests. and then kind of execute them with and implement them with whatever sort of tooling that you want. We decided to go with this because we wanted something that would empower the QAs in order to be able to write tests, because we didn't understand the program as well as we knew that they did. And so we wanted to make sure that whatever we wrote, other people could kind of write the tests, and we figured, all right, well, great, we can do a lot of the maintenance for that. And it was backed by Selenium and Appium, because as we said, we really were looking at things initially from the UI side. And they had both a mobile and a web component to their application. So they had a native Android app, they had a native iOS app, and they had a web application that they ran as well. And so what we decided that we wanted to do was, well, we wanted to be able to write one Gherkin test, so one given when then test, and have it be able to be implemented with both Selenium for the web and Appium for Android and Appium for iOS. The idea is you have one test and you can kind of run it anywhere, which really is a fairly good strategy. The kind of problem became, and this is one of my personal issues with Cucumber, is and what we didn't find out until later is that none of the QAs had any interest in writing Gherkin tests. They wanted to write tests on their own. They wanted to be doing exploratory testing. And even though management said, hey, yeah, maybe you should kind of do this, there really was never a strong push for them to be empowered or for them to even be encouraged to use our framework. And this was something that would have been really good to find out up front, and I'll talk about a little bit more of the drawbacks later on. But basically, we used Cucumber for that one good reason about being able to write one test and run it anywhere. But a lot of the problems became, well, we used a framework and we included a lot of overhead that caused a lot of problems, and I'll talk about some of the problems later on, but that didn't necessarily give us a lot of benefit because the organization was not doing BDD. The Three Amigos discussions were not happening during sprint planning. Testers oftentimes weren't even involved until after the sprint, and they're told, hey, test this afterwards. I mean, again, all of these really say that we're doing a lot more work with Cucumber than potentially is really worthwhile. That said, we did want to make it so that we could have other testers participate. And I'll talk about how we kind of slowly changed the company culture a bit, with some success and then with a little bit of failures as we went through. Another anti-pattern that we followed was we ended up using a separate repository for automation. I personally am very against this. I believe that your automation is code. It needs to live in source code, but not just should it live in some sort of source control repository system, it should live right next to the actual source code in the same repository. Because as the actual code is updated, your tests need to be updated. And if they're in two separate repositories, you have the issue of, well, I'm going to change my code. What version of my tests go with what version of my code? Well, I've changed my tests. Now what version of my tests go with what version of my code? And you kind of have a lot of these problems where you either need to set up some sort of nice instance of tagging, or you really need to be in sync. Whereas if everything's in the same repository, it's very easy because you're not trying to check out things. There's no disparity between the two. That said, we ended up going with a separate repository because of the complexity of the system that they were building. This was one huge monolithic application that was split out of between about 12 different repositories. And the Android application was kept in a different repository as the iOS application, was kept in a different repository as the web application, which makes sense. But then the different backends were kept in different locations, and then the APIs were kept somewhere else. And the problem that we ran into is even though the web, the Android, and the iOS app all had the same workflows as far as the front end goes, which means we could in fact write one behavioral test, the same test for all three, they were each implemented very differently. And so what happened was, well, had we stored all of our tests with the web app, we still would have had problems syncing up with the Android and the iOS app. Well, had we stored them with the iOS app, we would have had problems syncing up with Android web and so on. And so we figured, well, if we're going to have to worry about syncing up with 2 or 3 different repositories, may as well just make it 3, because if we're going to have to be doing some of this work, may as well have our own repo so that we can kind of have as much access and mess around with whatever we need. And access was a little bit of an issue. And again, I'll talk about that a little bit as time goes on. One of the other big challenges that I always run into with building out BDD frameworks is, where is the source of truth? Because ultimately you want non-technical people to be able to write your tests, but your non-technical people don't necessarily want to be using source control because it's a technical thing to have to check out code, to have to make changes, to have to push them. You may have to stash, you may have to check out different branches, etc. So what we ended up doing was we ended up using Git as a source of truth, meaning that all of our given when then tests were stored in Git right next to our framework, etc. But we created custom hooks for Jira. We were using the Atlassian tool suite, and Zephyr, which was the Jira plugin that we were using, so that any single time that we made a change to our test cases in Git, Jira automatically was updated and it reflected all of those updates. Now you couldn't make changes in Jira and have them pushed into Git, which we had to slowly train people. But it did mean that if you wanted to look and understand what the tests were that we're currently running, it wasn't a huge deal. We also had an open source Gherkin Builder tool that we kind of created, contributed to, etc., that we released, that allowed non-technical people to be able to write the tests in a nice web UI in a given when then format, and it would automatically pull from all the regexes that we had for all of our tests, and it allowed us to really let non-technical people write everything. You click save, everything gets stored into Git automatically, everything gets updated to Zephyr, and so it allowed for a lot of traceability within there. So while we were doing this, we actually had a separate team that was brought on about a month and a half after I started my work, that was building out a development pipeline, a typical DevOps pipeline. And so what we started doing was we started integrating in our automated functional tests to the pipeline. And a few of them actually became part of the continuous integration effort, the CI. So part of their CI, they would deploy the application and stand it up and do a quick curl and say, hey, is the app up? And we said, oh, well, if you're going to do that, why not run 5 of our tests? That's all we wanted. Just let's make sure that not only did a page come up and give you a 200, but can you log in? And can you access several different pages? Which worked out, really well. And initially this was great. Because QA suffered a lot from they'd be delivered builds and they'd be installed on their system and nothing came up properly. And so by doing this, we knew that at least the system would come up. And so we immediately, just by doing this, started saving QA a lot of time. And we were, they started using Kubernetes, which meant they could very easily stand up a new environment, run whatever test they needed, and then destroy it. And so, once we had some of these functional tests in there, the developer started seeing the value of it. The QA almost immediately started seeing the value, and the whole organization started actually contributing tests to the repository. And so we actually started seeing the CI tests being built out. We started seeing more API tests integrated in the pipeline. We started seeing more unit tests and more integration tests being integrated in, which was great because they started catching issues, which was exactly what we wanted. The problem came when tests started to fail, because tests, of course, do fail. You change something and tests fail. And code was getting held up for it. And as I said, we had some issues with the organization. There was a little bit of issues with trust. There was issues with us just wanting to bang out work as quick as possible. There was a lot of management trying to push things through as fast as possible. And one of the things that comes with that is a lot of finger pointing, because when your code was progressing just fine, you introduce some tests, and then the code stops progressing, well, there are several discussions that can happen, and ultimately the discussion that did happen on this particular project was, well, things were running just fine without your tests, you introduced the tests, and now nothing's working. Solution? Remove the tests, because as everyone knows, in a good functional space, it's clearly the test's fault for not working. So we had a lot of problems with, well, it's not actually the test. You're actually producing bad code, as we knew, and this is exactly how qualities were making it into production. But management really didn't want to hear that, and we didn't have any way to prove it. That didn't take a long time because we had to do triage, we had to understand what the issues were, etc. Additionally, QA really didn't like the way that we were writing tests. They really wanted to be doing tests in your traditional style, was they expected us to be writing long end-to-end tests using the UI, and that is very fragile, it's not maintainable, and it's going to just take a long time to get things done. And so we had to undergo a lot of kind of training for that as well. Not to mention, it was very difficult to test all of the different applications from the front end. Android and iOS are inherently slower to run than web applications. It's much harder to stand up a new Android emulator, a new iOS simulator in a Kubernetes environment. And there just wasn't a lot of trust from the results of the tests. There was a lot of false negatives, and we were even more worried about false positives, that we never found any. But the truth was, we were shifting from your static environments to your dynamic environments, and they were having a lot of problems with things that would fail in the dynamic environments that would run just fine on your static environments. And so of course it's got to be the tests. They're doing something wrong. But of course that wasn't actually the case. It wasn't that we were having a problem with our automated tests. It was, well, the environments were actually configured differently. And while we were eventually going to be getting rid entirely of our static environments and using Kubernetes in production, until that happened, it kind of looked like things were going wrong. And so what we needed to do was we needed a lot of proof that our tests were actually working and that it was either a bug that was introduced or another problem with the system. And so what we ended up doing was we ended up creating a matching pipeline for tests. So what we would do is any single time, well, initially we took the latest version of the application, we ran our tests against it, and everything passed. Great. So we knew that version X of the application worked with version X of the tests. When we updated our tests to version Y, we reran them against version X of the application. When version Y of the tests passed, we said, great, version Y of the tests works against version X of the application. So we know that these tests are good, and we have no problem pushing these changes out and forcing the developers to use them. When the developers then release version Y of their application, if there's a failure, it's for only one of two reasons. The first reason is because they actually introduced a bug that wasn't there in the previous version, because the previous version the tests worked. Or they introduced a change, which is a known change that they did not communicate out to us, that the tests should be failing because they need to be updated. And what that allowed us to do very early on is reduce the amount of time of triage and point out that it is not a problem with the tests. It is either a problem with the application or it is a problem with communication. And it took the better part of a month probably before this really set in. But what happened was the developers started gaining a lot of confidence, and they really liked having these automated tests in there because they realized that, hey, they were catching bugs, and when there were changes, they really wanted to be upfront and working with us in order to make sure that the test would then pass, so that any future changes any future bugs, would be caught as well. The other thing that we really kind of had to harp on is because of some issues that kept cropping up periodically, a lot of people got in the habit of just rerunning a build or rerunning the tests. Well, test X failed, so let's just rerun it, and then it passed. This is a huge problem that in general I have. I could probably spend another 1 or 2 talks just diving into this. But what the underlying problem we eventually discovered was it was an unstable application. They actually had timing issues in their database, they had threading issues, etc. But when they would rerun the test and the test would then pass and they'd say, great, there's no issues, they were literally just hiding the underlying bugs and the issues. And actually this pipeline helped it a bit more because we could say, look, we ran this multiple times, and 50% of the time either there is a failure, it's not just a one-off, and it's not necessarily even a problem with the tests. Because the tests don't have any hidden timing. And so by building out this pipeline, we were able to really build and instill a lot more confidence in our actual tests. And so what we saw was really a cultural shift. We had a much more engaged team mentality because quality was no longer something that, well, testers did. It involved the entire organization. And the developers really wanted more tests, and they wanted them at all levels, and we really saw everyone kind of contributing to it. And as a result, releases just started getting easier, and they were able to cram in more features. I mean, yes, we spent more time and effort, but they also saw more features getting out a lot more rapidly. And there was both automated and manual testing being done at a more rapid pace as a result of this. So, as I said, it was a little bit of a rough culture, and we did actually uncover some really good issues with the application. As I said, some threading issues, some timing issues, but management really pushed back a lot at a certain point. When I actually ended up leaving the project, it was because they had some new management take over who did not like the fact that failing tests were stopping builds. They really just said, I don't care, we need to get this software out, we're under deadlines. And so they actually started stripping tests out. We'd gotten pretty much almost all the way there to continuous testing, all the way from testing down to the unit level, doing some of these BDD activities, to doing our testing relatively late in the life cycle as well. And these tests started getting pulling out, and it was really just because of this, again, another change in mentality of management shift, bad deadlines, and tests were just seen as blockers. They were seen as more problematic by this new management who hadn't seen all of the success that we had earlier had. And personally, it was a bit painful for me to have to go through this, watch all my work get ripped out. But it was because this organization had transformed so much because of the testing that we had done, that people who weren't kind of there and were aware of the real value that this added didn't understand what they were kind of pulling out and what things were going back to, which ultimately really was a huge detriment for them. So just really briefly, I do want to give you a few lessons learned, which is, just start small, don't try and boil the ocean, don't try and accomplish everything. Make sure you select the correct tools that fit the process, not the other way around. As I said, we kind of went a little bit backwards into this, and we did it knowingly, but it still ended up kind of being a bit painful. One of the things we always used to like to say is, well, if nothing's your fault, you're probably wrong. Basically, again, a lot of finger pointing, a lot of people saying, well, it's developers' fault the testers are failing, oh, it's the ops' fault the tests are failing, et cetera, et cetera. When we actually got everyone on the same page, it was very easy to figure out what the problems were, but a lot of times we weren't empowered to do that. We weren't even encouraged to do that. It was much easier to say, someone else will fix it, it's someone else's problem. As I said, culture is really hard to change, and we started seeing a lot of successes, and the people who recognized those changes were vital to helping keep that ball rolling. But as things changed, we really did see the organization fall back on what they were comfortable with, which really was kind of unfortunate. And that's my talk on continuous testing. So hopefully you guys have been sending some questions in chat. I'll go ahead and try and answer whatever I can now. And I'll be around for the panel discussion at the end. If you guys have any questions, my Twitter handle's down at the bottom. I hope you guys were tweeting during it. Here's all my contact information and all of my company's contact information. Hope you guys have a great rest of the conference.
Thank you, Max, for sharing this excellent case study with us. Audience can log on to slido.com and enter code #3648 to drop your questions for our speaker. The details are also available in the chat section. This Slido screen will be open for 3 minutes now. So we have a question for Max. What is the right automation tool and how to select the right automation tool? Over to you, Max.
Over to you, Max.
Hey, can you all hear me? Can you hear me okay?
Yeah, we can hear you.
Yeah, we can hear you.
Excellent. So that's actually a great question. When you talk about the correct automation tool, there really is no one correct tool, but there are definitely a few things that you want to be looking at and you want to be thinking about. And the main thing that I would probably consider is what language is your application being written in, and what language are your testers or whomever is going to be writing the tests comfortable with, and kind of start there. So if you have a Java shop, choose some sort of automation tool that's based in Java. If it's a Node shop, you want to be looking at JavaScript, you want to be looking at Node, etc. The next thing you really want to be looking at is the level of testing that you're looking at, whether you're looking at testing UI, API, and what sort of your requirements. What traceability do you want? Do you want something that can easily take screenshots, that can easily tie into your test management software, etc.? And kind of choose a tool that fits your process as opposed to the other way around. I'm a big fan of experimentation, and maybe try out a few different tools, see what's easiest to work with, and move on from there.
Okay, so we have
another question. How do you ensure that there was focus on? Oh, go ahead.
I'm sorry. Yeah, I was just reading the question, Max. Please carry on.
I'm sorry. Yeah, I was just reading the question, Max. Please carry on.
Yeah. How do you ensure there is focus on looking at tests that pass on rerun? As usually these are considered lower priority. So that's actually a great question, and something that we ran into a lot of problems with, because I even had both testers and developers who were rerunning the tests and just saying, well, it eventually passed, so it's fine. And I know this is very common. I hear a lot of shops say, we keep track of the failed tests, then we rerun them. And my question for you is kind of, well, if you're going to rerun the test, what value does it provide? Because, if it's a bad test that has to be run twice, if it ever fails, is anyone really going to believe that it's a failed test? Or are people just going to assume that, oh, you have to run it again and you have to run it again? And so one of the things that we did was we were very adamant failed tests if we thought at all it was a problem with the test. For the testers, we kept track of every single PR, and we could see how many times the pipeline had to be run. And if it had to be run because of failed tests and nothing was changed, we literally kind of got into it with some of the testers. And it was really about, well, if it was a timing issue with the test, great, you have to rewrite the test, you have to make it better, because there were in fact timing issues with the app that caused problems. And so once we made sure that all of our tests could run consistently, and it wasn't a problem with the test, then we were able to really push back on the developers and say, hey, if you have to rerun the test, it is definitely a problem with the application. And we had to dive into the code and show them, hey, you have threading issues. So we did profiling on the application. We took on a little bit more ourselves than I think is common for most testers, because we really wanted to prove that our tests were stable and this was not a problem that we were causing. I see another question about videos or tutorials to implement Jenkins in execution workflow. I'm not really aware of any that are out there. A lot of this has just kind of come from, my experience with building out different pipelines. If we have time for one more question, how many scenarios did you actually run before creating the build? How can we actually derive appropriate? That one ran off. But as far as how many scenarios did we run before creating the build? So we would run all of the tests that were particular to the area of code that was being changed. And once we were confident that all of those tests ran successfully, then we were okay with kind of merging in the new feature, and then we would run our full set of regression. So sometimes that was 4 or 5 tests, sometimes that was about 15 to 20 different tests at the UI level. But towards the end, we had a lot of API tests, we had a lot of unit tests, like thousands of unit tests, and hundreds of bunch of testing that was going on. Let's see. So I'm just going to look at the top question. What input should we get from development team while designing the automation framework if we want them to use it actively? So a few inputs that I would probably find out from the development team is, what languages are they comfortable with? What frameworks are they comfortable with? And really, what is their development process? And what build tools are they using? What IDEs are they using? I mean, I would almost environment in their process and come up with something that's very, very easy for them to run. We had the most amount of success actually when we provided a Docker image that had all of the tests on it, because we were, as I mentioned, shifting over to Kubernetes, and so everything was run in a Docker container. And so what we did was we said, great, you guys are used to doing a Docker run and standing up the application. Well, here, take this container and do a Docker run, and it will run all the tests. And because that fit really, really well in with the current process for the developers, I've been in other environments where, they were able to just kind of in their IDE click on the execute XUnit test, whether that was PHP unit or whether it was JUnit, and they were able to run the functional test the exact same way that they would run their unit tests or their integration tests. And that, again, made it were much more apt to actually run those tests on their own. So let's see. Is it wise to bring in test automation in a process where the module is not using a lot of industry standards, but instead a lot of custom solutions. So I would say definitely yes. I don't personally think that you can be successful without doing test automation, and that's mainly because the amount of the application that you have to be testing is constantly growing, whereas the developers are not going to be constantly, increasing the amount of work that they do per build, which means you're always going to be doing more work than the developers from the previous sprint. And so without automation, you're not going to be successful. What it means, though, is you might need to be a bit more specific about the automation tools that you're using, and selecting the right things to kind of fit into your own solution. I don't think that it means that automation can't work or can't be successful. It just means that you may need to use different tools than other people are potentially using. But most tools that are out there, I think, are probably flexible that can fit in to whatever it is that you're looking at. Is there guidance you follow for test maintenance in the long run, since the amount of time needed for and flakiness can increase a lot over time? So there are a lot of different things you can look at, and I'll touch on just a few here. I think we have a panel discussion later, which I think would be a great thing to talk about. But a few things that I really like is I avoid testing at the UI level. I avoid exercising the application at the UI level unless it's something that I'm specifically trying to test. So I'm not a fan of long end-to-end automation tests. A few of them are fine, but typically, if all I care about is one particular feature on one particular page, I am not going to log in through the app on the UI and navigate all the way to that page and then exercise that function. I'm going to log in through the API, grab that token, shove it in my browser, go directly to that page with directly that functionality, and then from the UI, I'm going to interact with that feature, make sure that it works properly, and be done with it. And what that does is it speeds up my test and adds a lot more robustness to it as well, because it ensures that I'm not testing all of these other things along with the one feature that's also under test. So I should have other tests that are going to be testing the login page, they're going to be testing the navigation, that's going to be doing everything else. But why actually go ahead? A lot of design patterns that support this kind of idea, but one of the big design patterns that I see pushed a lot is this page object model, which is really, really useful for creating common code so that when your application does get updated, you only have to change things in one spot and all of your tests automatically reflect those that new workflow or those new updates. But you want to be careful to make sure that the page object model doesn't kind of lull you into this idea of everything needs to be done through the UI, and I should be continually reusing these steps over and over. If you're familiar with the arrange act assert pattern, which is get my test, get my system set up in a known state for my arrange. Act is perform my actions and then assert. I'm a huge fan of that. It's common in unit testing. I try and use that for my functional testing as well. But basically, all of my arrange, I try and do not in the UI. I try and make my I try and make my act as minimal as possible through the UI, and then I make my assert, and that speeds things up and makes things a whole lot more robust and leads to a lot less maintenance. Sounds like no one's cutting me off, so I'll answer the another question over here. Any best tools you suggest for Java Swing-based UI applications? I mean, if you're if you're building out a UI application, if this is for the web, you can use UFT, you can use Selenium, you can use Squish, any of those tools. They all work just fine. Selenium is probably the most common at this point, so I would probably push you in that direction, especially as it is a free tool. But that doesn't mean it's necessarily the best. It really kind of depends on what everyone in your organization is comfortable with. Yeah.
Thank you, Max, for answering all these questions. And any further questions, if they come in, we will keep them for the panel.